Morning Year 6, welcome to Maths after the initial assessment and some catch-up work today. We're off and running. It's a unit of work all around area, perimeter and volume. I just want to point out to you that this unit of work has a lot of new learning in it. Just going to collect myself in case I'd like to do some jottings. So we're going to start with some mathematical talk as part of our review. What do you need to know in order to work out the area of a shape? Why is it useful to know your times tables when calculating area? Can you have a square with an area of 48 centimeters squared? Why? How can factors help us draw rectangles with a specific area? Pause the video, work through each of these questions, writing down your knowledge or your thoughts, ideas. This diagram I gave to you yesterday. It's really useful as part of a review. Let's go through the questions, see how you did, and maybe use this to help. What do we need to know in order to work out the area of a shape? Well, there are a few things I think we need to know. We need to know that the area is the size of a surface. It's the surface space that a shape is taking up. I also think we probably need to know the length in this case and the width. I wonder if we need to know anything else. What did you think? Why is it useful to know your times tables when calculating the area? Well, in year 4, it's very much putting the shape or drawing the shape on 1 centimeter square paper and counting the squares. So if you count all the squares that this shape covers, we end up with 12 squared centimeters. Progressing that on, it then becomes a calculation. So we have 3 multiplied by 4. This is the formula. Length times height, or length, width. So one side, the longer side, multiplied by the shorter side. If it was a square, all sides would be the same length. So times tables, 3 4s. Bingo, 12. How can you have a square with an area of 48 centimeters squared? Well, this is the way I looked at it. I was thinking, if something times something equals 48, is 48 a squared number? Seven sevens 48. Is that right? Have I got that right? If I have, then that would be fine, because it'd be a 7 by 7 square. Okay. How can factors help us draw rectangles with a specific area? So if you're given an area to draw, well, factors of 12. So let's imagine that we have been asked to draw a rectangle with an area of 12 centimeters squared. So there's the 12. What are the factors? Done them as pairs: 1, 12, 2, 6, 4, 3. You could draw any of those. This is the one we have over here, 4 times 3, or 3 times 4. Commutative, so it doesn't, though it's length times height, the answer is always going to be the same. Great. How did you do? If you got stuck on any of those, pause the video, review it, and have a think. Ah, okay. So you're telling me that 7 7s aren't 48. What 7 7s are? Okay, 7 7s are 49. Well spotted. So can you have a square with an area of 48 centimeters? Well, who needs to do a bit of work on their times tables? 7 7s are 49. So 6 6s 36, 7 7s 49. I've gone over it. So it's not possible. Well spotted. Thank you for picking that one up. So have a go at this explore question, sorting the shapes. This is called a Carroll diagram. Go through each of the shapes. Do they fit in one of these or not? And then when you've done that, draw another shape. I would recommend labeling them A, B, C, D, E, and then you can pop the letters in here. Draw another shape for each section. So draw your shapes, label those. So we're up to E. So go F, G, H, I, J. Pop them in there. Pause the video. It's going to take a little while for you to think that one through. Okay, let's see how you did. So A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Doesn't seem to fit. A does not fit into the Carroll diagram because, why is that? B, 2, 4, 6, 8, 10, 12. Four-sided shape? Yep, quadrilateral. So I think it goes there. 1, 2, 3 times by 1, 2, 3, 4. It's 12. It's a four-sided shape. I think it goes there. D. 1, 2, 3, 4. 1, 2, 3, 4. 4 fours are 12. Yeah. No, they're not. 4 fours are 16. Well spotted. So we're coming back to that point. Need to know my times tables, don't I? I'm really, really grateful for those people who are picking me up. So we've got 4 fours are 16. Yep, brilliant. 16. Is it a quadrilateral? Well, it's a square. Yep, there we go. How about this one? We could count them. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12. Not a quadrilateral. Yeah, hasn't got 4 sides. It's got 1, 2, 3, 4, 5, 6 sides. How else could we do that? 2 2s are 4. 2 4s are 8. Add those together to get the same answer. Yeah, a little bit of reasoning here. Rosie and Dexter drawing shapes with an area of 30 centimeters squared. Who's correct? Explain your reasoning. Try to go at that one. If you want to draw that shape out, don't draw it to scale because it's big. So just draw it not to scale and label it. Other question: always, sometimes, never. if the area of a rectangle is odd, so odd numbers, then all of the lengths are odd. So what are you going to do there? Try some out. Does it always work? Sometimes you can't make it work at all. Pause the video. Have a go at those. So there we go. Both are correct. And here's some reasoning here. So pause the video, have a look, particularly at this one. So a half times 60, that should be very easy for you. This one, however, because it's the area, somehow you want to split it, but it could be split in different ways. So I've just happened to have done it across that way. It could easily have been done that way. What was your reasoning? In maths, the workings out can easily be the reasoning. Always, sometimes, never. Sometimes. There's an example. What other examples did you have? Let's do checkpoints. Each of the rectangles have the same area. I've labelled them. I think it's a good technique. X, Y, Z. The area of X is, the area of Y is, the area of Z is. Therefore, answer the question. So pause the video, show your workings out. There we go. True. Each of the rectangles have an area of 24. Did you get that? It comes back to this times table. Who's going to help me out? 3/8 are 24. Centimeters times centimeters squared. 24 centimeters squared. 6 4s. Yep, 24. 2 12s. 24. Remember to put the units of measurement. So if you've got a centimetre times a centimetre, you've got a centimetre squared, just as any other number would be squared. 4, made up of 2 2s, for example. Pause the video, have a reflection if that didn't quite work out for you. Go back over it and have a go. Length times height, length times width, one side times the other side. So over to you, some independent work. Today, complete all the questions. I'll put a printable version on Dojo and the answers on Dojo. The steps are so that you can see the progression in what I believe is the difficulty. So 1 to 3 being easier than when you get up to 6, 7 and 8. The general progression is that way. You might disagree. Great. First thing to do, if you get a little bit stuck on anything, the great thing is you can replay the video. Pause it and replay it as many times as you like. If you're still a little bit flummoxed and you want some advice, have a word with people in your study group or reach out to me, and I'm very happy to help. Good luck with the maths and take care, Year 6.